Well, hello, and let's go ahead and solve a system of equations. I'm sure you remember doing something similar to this in 10C. The difference is we will always have at least one equation that is a quadratic, so it'll be a little bit more exciting, but otherwise the process should be very, very similar. This is a nice way for us to start to wrap up the course. So let's start with looking at a linear quadratic system of equations, and let's see how we can substitute. So the way I like to approach this is I'll take a look at the two equations and isolate, pick the easiest looking equation, and then isolate for the easiest variable. Then, once I've isolated for the easiest variable, sub what you have into the other equation. Don't sub it back into the equation you just had. Solve. Then you're going to take that solution and sub it into either equation. It doesn't matter which one at this point. And then you're going to solve once more. There is a step 6 where we say you should verify. I'm not going to ask you to verify in this course. I think this is one of the places where we can shave off a little bit of time with us just looking at 3 hours a week of learning. So let's go ahead and solve this one algebraically, and let's solve this one through substitution. I like to number my equations right away, so I'm going to call this one 1 and 2. If you number your equations, I really encourage you to circle those numbers though. If you just put a number in front, it can be a little bit confusing. It can look like it's a coefficient. For example, look at this x squared. If I call that equation 2, it looks like I'm saying 2x squared. You put a circle around that, it's a lot more clear. So I do like to number these equations, but I like to circle those numbers as well. Now, I think anyone would look at this and say equation 1 looks easier because step 1, we need to isolate for the easiest variable. I think we're all going to say, let's take equation 1 and let's isolate for the y variable. So if I had 5x minus y equals 10, I would subtract 5x from both sides and I would have negative y equals negative 5x plus 10. I would just change all my signs so that I would have y equals 5x minus 10. And this is still equation number 1. This is why I like to number these things because I want to keep track of what the work is that I'm doing. So step 2, sub into the other equation. So what I'm going to do now is say equation 1 goes into equation number 2. So I have equation number 2 says x squared plus x minus 2y equals 0. Now notice instead of a y, I wrote a set of brackets, but that is nowhere near enough room. What I want to do is instead of subbing in this y here, I want to sub in what the y equals. I want to sub in this 5x minus 10. So I'm going to literally take this 5x minus 10 and I am going to put it in the place of the y. So like that, I have subbed equation 1 into number 2. Let's go ahead and solve for the x variable. Notice what we've done is we've gotten rid of the y variable. Now we're just dealing with x's. And notice we now have a good old-fashioned grade 11 equation. We've got an x to the power of 2. Let's go ahead and simplify and solve this one here. X squared plus x minus 10x plus 20 equals 0. X squared minus 9x plus 20 equals 0. Joy of joy, we get to factor this. So we know that we end up with x minus 4, x minus 5 equals 0, which means that x equals 4 and x equals 5. Now, if we were just solving a regular equation, we would be done, but we're solving a system of equations. And when we solve a system of equations, we need a full coordinate. We need an x and a y. That's why our next step is going to be sub into either equation and then solve. So I'm going to take a look at my two original equations again. Here's number 1, here's number 2. You can sub x equals 4 and x equals 5 into either equation. But I think you would agree, let's take a second and say, wait a minute, equation 1 looks way easier. Let's just do that, please. So taking my 5x minus y equals 10, I'm going to sub this into equation 1. And so I have 5x minus y equals 10. And notice, instead of the x, I put a set of brackets, and this is where I will sub in a 4. We now have 20 minus y equals 10. Negative y equals negative 10, y equals 10. What that means is when we have x as a 4, y becomes a 10, and that becomes our first solution. Let's go back, and now we have x equals 5. Let's sub that again into equation 1. You could sub it into equation 2, but why? Why would you want to do all that extra work? Once again, we have 5x minus y equals 10. We know that the x is a 5, so we sub that 5 in for the place of x. And now we have 25 minus y equals 10, negative y equals negative 15, y equals 15. Of course, what that means is when x equals 5, y is a 15. So we can now write ourselves a little answer statement. Therefore, 4, 10 and 5, 15 are the solutions to this system here. Now again, there is one more step where I would say let's go back and sub these points in. It's going to be just fine. It will work out. There's really only a few times in Math 20 or Math 30 where we have to absolutely verify, and I'm not convinced this is one of those times. Verifying is a nice to do in this case. It's not a need to do in this case. As usual, go back and watch this one. I suspect you'll want to watch this one a couple more times. Get these work examples into your notes. Then go ahead and move on to the next video. And as always, any questions, that's what the D12 discussions is for. Good job, good luck, goodbye.